Greetings to all. I am Mahesh from first year AAA department at Kamaraj College of Engineering and Technology. Today I make a project about a face-centered cubic structure with the help of the 3D model. The 3D model is made up of with a glaze and stainless steel. Definition of the face-centered cubic structure is the total number of atoms present in or shared by a unit cell is known as the number of atoms per unit cell. There are two types of atoms are present in the face-centered cubic structure. 8 corner atoms are present in the corners and 6 face center atoms like top and bottom, left and right and front and back are the face center atoms. We calculate the number of atoms in the face centered cubic structure. First we calculate the total number of atoms in the corners. So the total number of corner atoms is shared by 8 unit cells and the total number of corner atoms is 8. So 1 by 8 into 8 is equal to 1 is the total number of corner atoms, and then number of face centered atoms is equal to the face center atoms is shared by 2 unit cells and number of total face centered atoms is 6. So the number of face centered atoms is equal to 3. So then total number of atoms in FCC structure is the addition of the total of corner atoms and face center atoms. Then the total number of atoms in FCC is equal to 4. Then we calculate the atomic radius of the FCC structure. We consider this part like this. It is considered as this 4 atoms like A, B, C. This is a distance with the R and R. This is 2R and this is denoted by A. So this we conclude a right angle triangle. We apply Pythagoras theorem. So AC square is equal to AB square plus BC square, then A square plus A square is equal to 2A square. Then the answer of AC is root 2A. Then another way we calculate the AC is the total distance between the A and C is 4R. Then we equate the answers of AC is equal to root 2A. Then R is equal to root 2A divided by 4. This is the atomic radius of the FCC structure. Then we calculate the packing factor of the FCC structure. Packing factor is equal to volume occupied by the number of atoms per unit cell is divided by the total volume of the unit cell. So the radius is equal to root 2 into A divided by 4. Then the volume of the atom is V is equal to 4 by 3 pi R cube. Then the volume occupied by the unit cell is equal to the total atoms per unit cell is 4. Then the volume of the atoms is 4 by 3 pi R cube. Then the volume occupied by the number of atoms per unit cell is equal to 16 by 3 into pi R cube. Then we substitute the R in the V. 16 by 3 pi into root 2A by 4 the whole cube, which is equal to 16 by 3 into pi 2 root 2 into A cube divided by 16 into 4. I write the 4 into 4 into 4 is 4 cube. Then we cancelize the 4 into 4 and we cancelize also the 2 by 4. We balance the 2. Then we conclude the volume occupied by the total number of atoms per unit cell is equal to pi A cube into root 2 divided by 6. Then the volume of the atoms per unit cell is considered as A cube. Then the packing factor is equal to pi A cube into root 2 divided by 6 divided by A cube. Then we calculate the packing factor. Pi A cube into root 2 divided by 6 into 1 by A cube. We cancelize the A cube. Then the answer for pi root 2 divided by 6 is approximately 0.74. I concluded that the packing factor of the FCC structure is 74% of atoms are occupied in the FCC structure and 26% of volume is vacant. Thank you for the golden opportunity to my physics professor Dr. M. Santi. Thank you all.